Hi everyone, this is John here. I've been working in the IT industry for quite some time in the integration area. Today I'm going to talk about a topic called as Agile Integration. So what is this Agile Integration? So before going into Agile Integration, it is necessary that we should understand about how IT industry has got evolved. Like if you see IT industry, it has been evolving for quite some time and it has been very rapid for the past for 5 to 6 years. You see a lot of changes have happened. So those changes broadly we can classify it into three categories: from the architecture, design, people and process, and the infrastructure and technology. Inside the architecture and design, you'd be having AI, ESP, service-oriented architecture, REST, microservices, APIs, all these things you have heard about it. And similarly, in the process, people in the process, you have heard about decentralization happening. Autonomy has been provided for many of the projects, and similarly, agile way of integration that also has been brought into picture. The same way in infrastructure, we would have heard about virtualization, containerization, and cloud. So each and every topic is it itself is it will take a lot of time to talk about it. I have prepared a separate videos for each of these topics. I recommend you to go and look into it. Thank you. So next, we'll just go and see how these things have got evolved, at what duration it got evolved. That is what I have added it here in this particular slide. So if you see AI started in 1990s, ESP 2008, resource architecture came in those timings. Same way, if you see here, all these things are still relevant. Nothing has got outdated. Still, they are relevant in the IT industry, but it has got, I would say, they got transformed into different form. So that is what we are going to see in this particular topic. So let's first take architecture and design. So if you take first architecture and design, EI, you'd have heard about EI earlier. Point-to-point communication was there. Now we are going. The EI was overcoming it by the help of the hub and spoke architecture, where you have a centralized hub which would be helping us to connect all the applications. Next, but the problem in the EI is you would be having the centralized point of failure. That centralized point of failure has to be overcome, and that's where came the enterprise service bus that provided more capabilities like distribution of this particular integration service, and it provides some extra features like security, mediation, protocol binding, all these things. Some of the features which are not there in the namely in the EA architecture, it has been added as part of the ES. Next, we had the service-oriented architecture, where we were given the thought of thinking everything in the terms of services. That the concept of service consumer, service provider, service directory. So these are the things. This is the core of this particular service-oriented architecture was there. So this all came up, and at the same time, web services also has been sorry, excuse me, has been really popularized by Microsoft, and using the protocols using HTTP and data format using SOAP. So this also was another thing that was widely followed at the time. Service-oriented architecture was asking to think in terms of services. Web services also was thinking in terms of services, but it was mainly targeted towards the web world, and that also was here. Many people started following web services for implementing the service-oriented architecture. So this is how slowly we got involved, and the web services. When we say service-oriented architecture, immediately everyone will think about web services. So that is how it became synonymous. So whenever you say service-oriented architecture, it mainly helps us to think in terms of services. But if you want to think in terms of services, it is necessary that all the applications won't be in a position to expose everything in the form of services. So in that scenario, that there should be some kind of a bridge, or in other words, a kind of service which helps us to bridge the gap. So that gap or that particular tool is what we call as a ESB. So ESB is going to be the backbone of the service-oriented architecture. And if you see, this is the architecture you can see here. For whatever be the services, namely the connectivity services, data services, business services, all the layers of this particular service-oriented architecture, service bus is going to be the main bus which is going to provide this particular communication between all these layers. So service-oriented architecture has been implemented, or in other words, it is relying mainly on enterprise service bus in order to ensure this availability of services for the legacy applications. And that is where these bridge, I would say, this service oriented architecture ESB, they came very close to each other and it became inseparable. So this is how IT industry is currently is going in, and that is what they have been implemented in the IT industry for quite some time. For the past 10 years, you will see this is the architecture that has been followed in the entire IT industry. Next came the representational state transfer. So this is again an architecture style. You take a particular application or a service, and that particular way you have how you define that particular service, it has not been properly defined when everyone was started adopting service-oriented architecture and web services. That corrections, or in other words, the way it has been re-architectured, that has to be corrected. So that correction has been that is what has been brought out by the representational state transfer. It mainly makes use of that particular, namely the transportation layer, or in other words, the communication protocol layer, in order to do that necessary heavy lifting activities, in order to provide meaningful activities for the particular activity that we want to do on that particular server, or the reverse the resources that we have. So service again, for all these topics, these are just I'm giving a high level one. All for each and every topics you want to go in depth into it and you like to understand about it, my recommendation is go ahead and go and look into the separate videos which I have created. It will be very much useful. So now if you see microservices, again, you take a particular application, monolithic application, which is very complex, and if you want to have that monolithic application in the long run, it won't help out. So microservices insists on breaking that particular application to small application called as microservices, and then that would be able to easily deployable. So how this all is feasible? Again, the infrastructure that we are which we are having, it also needs to provide the necessary support. So that is where our when we go and see the infrastructure and technology, that kind of support has been provided. So if you see here, it is still service oriented architecture is used. We are still using the concept of REST. We are also using the concept of microservices. So everything is being used. Not that all the things have got away right now. Everything is still valid, but it is necessary that all this earlier technologies you should be aware of. So next we will go for APIs. APIs is nothing but application programming interface. So this application programming interface is not only specific for this particular world where we are having SMAC, but it is also applicable for also for the earlier days, namely even before this Mac came into picture. It is also available in the world of web programming and the hardware, web services, operating system, everywhere it is available. So APIs, again, it can be classified into two categories: technical APIs, functional APIs. Technical APIs are more towards targeted to the technology people, whereas functional APIs are more targeted towards the business people. So again, these APIs can be categorized into, based upon their complexity, can be categorized into simple and composite. So using simple APIs, collection of APIs, I can create a composite API. So if you see the real integration world, if you see whatever topics, whatever architecture that you all we talked about, so this is how it is. So we are going to have we are having all the integrations happening between the application via the integration hub. That is what the AI you are seeing, the blue color bars. They are all the integration ESB. That is what it is there currently. And if you those things, whatever services that they are trying to expose, it can be exposed to the outside world and also to the within the organization also. So how it has been exposed to the outside world, it would be exposed via the exposure gateway, or the enterprise gateway. Gateway is the one which is going to expose the services outside. The same way, if you want to expose the services internal to the company, in that scenario, you would be having the internal gateway. So, if you see in this particular architecture, all the architectures that we talked about, designs that we talked about, everything is incorporated in this single picture. So if you see in the people and the process, earlier days, what happened is, if you want to have the concept of, if you want to have this kind of integration happening, There will be a separate integration team sitting, separate system of record team sitting, separate application team would be sitting. And if you want to have any activity to be done between these integration teams, in that scenario, it would be necessary that you have to request the necessary team, and then there would be a long process. So this was causing a lot of problems, and similarly, each and every domain, or in other words, different departments. If there are some services they are hosted by a particular department, they would have the control. It would be the centralized integration team would be having the control. So that kind of problems were there. So these things were not helping the IT industry. So came the concept of decentralization. Decentralization is we are trying to give the ownership to the namely to the particular department, also the integration piece and also the application piece, whichever things that is relevant to that particular department, hand it over to the department. That is what we talk about decentralization. And so you are providing also the concept of autonomy. So since you are providing these two features to them, it is their duty to handle it. So this is what was happening, and as a result of which the team structure also has to be redefined. So when you start working on applications or microservices, the team structure would not be having only a group of technical people. It would be a mix of all kind of people. You'd be having architects, you'd be having developers, you'd be having Java testers, you'd be having operational people. All kind of people would be there, business people, everyone would be there. So this is how even the agile world, it is a world we have created a team of different kind of skill set, and that is how the agile world also thinks about. So this kind of evolution also has happened in the IT industry. So next comes the infrastructure and technology. The infrastructure and technology, if you see, we have the concept of virtualization, which is there for a very long time in order mainly to save the cost of the hardware. So in bare metal, for each and every system that you want to install, means every bare metal you purchase it, and then if you incorporate all the operating system, and then of course one of the application is going to be a tiresome way. So that's where the virtualization came into picture. Virtualization machines came into picture, but there also it reduced the overall effort, but it is not 100% reduce the effort. So in order to still further reduce the effort of the virtualization machines, came the concept of containers. Containers is nothing but it is the listing of the particular running process which is running in each and every in any operating systems. We can move across the operating systems, and also it can be moved anywhere. It can be within the on-premises or on the cloud, wherever you are interested in. You can lift and shift. So that kind of capabilities is what containerization brought into picture. So clouds, as I said, there are many clouds are available on premises, IaaS, PaaS, SaaS. So this compares what are the services. If it is on premises, you have to have every feature you have to take care of it. If in case of IaaS, only the infrastructure service up to virtualization, excuse me, would be provided by namely the service provider who is providing the IaaS service. And if you go for the PaaS, up to the runtime would be provided by the PaaS service. And if you go for SaaS would be provided fully. The entire applications would up to the application would be provided by the SaaS. Example for SaaS would be our if you take go for Microsoft Outlook, Office 365. These are some of the examples for SaaS. PaaS, OpenShift, and other things are there. IaaS, we have Amazon. We have many providers like Azure. Lot of IaaS providers are there. On premises, which is there in most of the companies, and still that is what we are trying to migrate. So this is takes a car as a service and see what are the things that you have to do. So if you are having on-premises can be compared to a car which is owned, and if you take infrastructure as a service can be compared to a car which is getting leased. Platform as a service can be compared to a car which is getting hired, and if you take software as a service, we can compare it to a taxi. So this is the way that industry people, everyone is interested to go towards the software as a service, because you need not do anything. All you need is for whatever service that you want, you pay it and then go ahead. So if you take when you are moving towards cloud, if you are earlier days, if you are on-premises, you have to take care of not only the code, whatever that you want to deploy. There are other things also that you have to take care of: resources, security, operations, routing, deployment, delivery. All this aspect has to be taken care of if it is in on-premises. This is what the traditional infrastructure is all about. Whereas when you go for cloud native infrastructure, only the artifacts part is what you would be handling. Rest of all will be provided by namely by the platform, namely the cloud platform. So if you see in this particular, there are many different what to say uh, capabilities that have been provided by the cloud platform. For example, delivery, it is provided by namely by Docker build, Jenkins, and other stuff. And resource allocation would be done by Kubernetes, deployment by Kubernetes, routing by Istio. Like this, we have many things that are there. So all these things have what to say got evolved, and many things have made a lot of changes to our IT industry. So if you see, now we are talking about infrastructure, how the deployments all are happening. So if you want to do a traditional deployment, everything will be in our control, but there is a cost to it there also. The what's the cost is it is very tedious to handle it. Whereas if you take in case of cloud native world, all you need to do is you have to take your runnable process or runnable image. You have to take it, and then you would be able to do the deployment. And once you do the deployment, rest of the things would be taken care by the cloud platform. So here is a comparison of what exactly has happened earlier and how the industry is moving towards now. Earlier, you used to have the code; it will be running in a fixed VM box where a runtime, environment configuration, fixed configurations are there. Whereas now we are moving towards a way where everything is there. The container is going to is going to contain the code as well as the fixed configuration as well as the runtime. So your runtime, everything is bundled in one single package. So as a result of which you don't lose anything, and this one you can take it all the way to the production without any changes in each and every stage. So this is a typical example in the world of IBM, how deployment, everything is being done the same way, whatever it is, the same image repository is what is going to be the you take a code. That code you have to you after doing the coding, all you need to do is you have to choose the right image repository, push it to that particular code to the image repository, then make it a deployable, or in other words make it a runnable version. So that kind of stuff is what is happening in today's world. So this, if this is the kind of architecture that is what is happening, so if you see in what is it, integration also needs to evolve as per the changes that are happening in the industry. So application integration, if you see, earlier you would be having a centralized ESP, and everything was handled, and then that would be taken care. It would be mostly non-premises. Whereas but since everyone is going towards cloud, and then we are going towards what is it, the people and process, everything is changing. Containerization, everything is happening. So also we have to go towards a fine-grained integration deployment, and decentralized integration is what application integration is all is happening. So application integration is getting transformed to agile integration. So this is the earlier diagram where you talked about the enterprise ESB. In that particular enterprise ESB, what you're having is you're having an integration hub. That integration hub we are breaking into small chunks, or we are making a fine-grained integration deployment. Decentralization is happening, and then we are moving all the integrations that are required to near the application. So that is the kind of integration goal we are moving towards. So we are moving towards containerization, application autonomy, as well as the polyglot. So these informations are all available in these references from Agile Integration links in this particular links. This really would be a helpful page where you'll be having all the details. Thank you very much for excuse me. Thank you very much for watching this video. If you like this particular video, go ahead and share your comments. It will be very much helpful for me to improve it further. Thank you very much for your timing. Have a nice day.